Woohoo! We have a full room. Hello, everyone. How are you doing today? I can feel the energy. That's amazing.
Exactly. Get fired up.
Welcome to this minus 40-degree industrial networking, where enterprise networking fears to go. My name is Emmanuel Taschen. I am one of the technical marketing engineer in the business unit. I am joined with...
I'm DJ Cole. I'm another one of the technical marketing engineers.
And I'm Albert Mitchell, yet another technical marketing engineer in the product management team for industrial networking.
All right. So with that, remember, you probably heard that already 100 times, but there is a WebEx app if you want to ask us questions. We will be covering our respective sections. DJ is the expert in everything wireless and not just Wi-Fi, while Albert is our in-house switching expert, and I'm taking care of the routing layer 3. Use the WebEx app if you want to reach to any of us. Yep. So, the agenda today is really to explain what is a ruggedized product. Why are we, IoT business unit, redoing everything that Cisco is already doing? Cisco is already doing switches, but we have industrial switches. Cisco is already doing routers. We're doing industrial routers. And Cisco is doing access point, and we do industrial access points. So we'll cover through the difference between ruggedized industrial and enterprise, and we'll go through some very cool use cases or where those devices are being used. Who is from, I would say, the industrial IoT space over here? Okay. Is everyone else in enterprise or similar? Okay, everyone is IoT. That's fun. So you're coming here to understand why you're using ruggedized products, I guess. That makes sense. Let's go through that. So this is one picture we got from a customer. This is a real picture from a cell tower in Norway. And we have a few routers running on that one. Those routers obviously have to support extended temperature range, which is one of the key signature, but not the only one. In industrial networking, where you're connecting things that are usually far away from the network, far away from the enterprise network, you usually don't have an Ethernet drop that you can plug in your router, and it's all managed and connected and secure all the way. It's connected over cellular or other technologies. So it's about connecting. But it's not about connecting computers, can be, but not always. It's about connecting things. Camera, robots, different kind of sensors. It's about connecting machines, diesel generator, and things like that. And in order to connect those remote assets in an efficient way, everywhere, under all circumstances, we need special products. So the industry that we are working with are using our equipment for a lot of different things. Personally, I am working with some of those, you can see here in the picture, I'm working with some of those customers, wind turbine, and in particular, offshore wind turbine. As you can guess, to connect an offshore wind turbine, it requires some special steps. Electricity distribution, rail and transport, roadways, as well as, for example, electrical vehicle chargers. So this is some of the verticals we play in, and whenever where we are, we need connectivity, whatever what happens. Is it freezing? Is it super cold? Do we have sold wind? Do we have water? Or anything of that nature? Okay, so for that we have ruggedization, but we also have certification, and that is very important. In many industries, you cannot operate equipment unless they have been certified for that specific vertical. Enterprise routers, Cisco enterprise routers usually don't bother to do that simply because, well, first they cannot. They will not sustain the testing, and I'll show you some pictures on how it looks like to do testing. But second, it's not needed. Usually those routers are cozy in a data center with air condition, fans blowing quietly. We don't have fans in IoT. I like to make this joke, we're not fan of fans in the IoT BU. Okay, so with the Cisco IoT product, what we did, we're not reinventing everything from scratch. What we do is we're taking the best we have in Cisco Enterprise. It's running iOS XE. It's the same iOS release. It has all the same feature you know from Enterprise, plus a few more. And we used all that technology in an industrial-grade appliance, router, switch, or wireless AP. So we can reuse all that investment we have, but we can also make the use a lot easier because everyone here, at least most of you, should know iOS XE. So it's just easier to continue to use iOS XE in a ruggedized chassis, in a ruggedized environment. Okay? There is a few more features. I'm sure Albert will talk about that for redundancy, particularly on the switching side. There's some particularities, and we have a different type of wireless technologies for IoT. DJ will talk about this. But generally speaking, we reuse the same thing across enterprise and IoT. The portfolio in IoT business unit, and that's something that even within Cisco, people are always very surprised. We are one business unit that does everything. We do switches, we do thin rail-mounted switches, we do rack-mounted switches, we do routers, we do routers with batteries, we do routers to be installed on top of pole mounts, we do a lot of different access points. We even have a specific network management platform called IoT FND, which is specifically targeted for some type of users. And we also have a range of products that almost no one knows about. Is the embedded range of products over here, where you can buy not just the appliance, but just the electronic circuit board in a way where it can be very easily integrated in your own design. I will talk about that. Okay, so I'll cover the routing part. Let's get started. We have a complete portfolio of products. On the top left, we have the IR1100. It's a DIN rail router. On the top middle, we have an outdoor router that is waterproof and also bulletproof. Yeah, do I say bulletproof because we use it in the US, and in the US they are installed on top of pole mounts. And these guys, and we have a very good specimen of that here, they like to practice shooting, and they like to practice shooting on those boxes. So we have to have some sort of gunshot compliance resistance test performed with those devices, in addition to the existing temperature range. Top right is going to be the embedded version. We also have on the bottom left, the IR1800, which is a flat mount router. The form factor is very different. It's not made to be installed in a rack. It's not made to be installed on a DIN rail. It's made to be installed, for example, in vehicle, behind doors, in concealed spaces. We have a more traditional Catalyst IR8300, which is like a router with a switch, with T1, E1, PTP, cellular, PoE, all of this together. So this is like the Frankenstein of all routers that is used primarily for substation automation. And we also have a number of modules. Those are modules for cellular, for network interface module like E1, T1, and similar things. So we have some modularity also in the chassis. And we do that because we want our product range to evolve with the future. The IoT customers deploy routers everywhere in remote locations. You don't want to change those routers every 3 years. You're not going to that location. Sometimes you're not going there every year. The first picture I show you with the antenna and all the ice and everything, the guy said there is only 2 months per year where we can go there with a car. The rest of the time, it's by helicopter. There is no other way to go there. So that's the kind of remote place we're talking about. Okay, so we build a design to be modular. It's modular so you can keep it longer and adapt to technology changes. We always have security built in. It's not bolt-on, it's built in. It's part of iOS XE. We have zone-based firewall, we have UTD. We can talk about that. From a management perspective, for the routing side of the business, we have either Cisco FND or Cisco SD-WAN. But I'm going to talk about that. In those routers, you have PIM slots. PIM, Pluggable Interface Module. This is how you use cellular connectivity for your routers. Because they are usually remotely located, whereas in the enterprise space, they use cellular as a backup. For us, cellular is primary. Cellular is the most important way we can connect remote assets. And we have a range of products. I'm not going through all of them. We changed a little bit the product range. If you were at Cisco Live last year, there was a lot more than that. But now it's kind of very simple. We have a very cost-effective, on the left, Category 4 LTE PIM module, which is not super fast, but okay for 90% of the use cases. Then we have a Cat 6, but mostly Cat 7, which is the new module. It's a little bit faster if you don't need the 5G speed, and if you don't want to pay for 5G, Cat 7 is going to do almost everything you want. Let's just skip Advanced Pro and go straight to 5G. So we have 2 modules for 5G. I recommend, unless you have very specific needs, to use the one on the right, which supports Release 16 of 3GPP, which can do 5G SA, 5G NSA out of the box, and it's using one of the best chip from Qualcomm, the SDX65. It supports all the bands, so this is really the big baby in the family. The advantage being that you can pick whatever module you want, depending on where you operate, what band you operate, the price bracket you want to operate within. I'm not going through the bands discussion and everything. That's a topic for another discussion. Let's review some of them in more detail. So the Catalyst IR1100, which is made for ruggedized environment, is a DIN rail mounted router. So it's made to be installed within an enclosure. It's not expected that you're spraying water directly on this router. So that's its primary use case. To be flexible, you can add expansion modules, but because everyone knows in a DIN rail, like you have probably an electricity breaker at home, there isn't enough space. There is never enough space in those DIN rails. So the base chassis you see on the right is the minimum size of the 1100. I don't have one with me, but that's pretty small. It's about 4.5 centimeter wide. And if you need more functionality, you can snap a module on the top or on the bottom. The one you see in the middle is one with 2 expansion modules. And we have expansion modules to do multiple different things, to add SFP ports, serial ports, cellular ports, and others. So depending on your need, not only this is modular, but also it always has the smallest possible size to accommodate what you need. Amongst those PIM cellular module, I want to make a special mention on the LTE 450 megahertz. So that's a frequency that has been reserved and used in some countries, either in Europe, but also in South America. 450 megahertz is used by generally utilities or defense. The particularity of the 450 megahertz is it's very low in the spectrum, and it has a very good penetration. So it can go really far away, or it can go really deep into structure, like in basements and everything. The drawback, obviously, is that the transfer speed is relatively low. There isn't many LTE 450 megahertz supplier and vendor out there, so that's kind of a unique positioning we have here. Another one is the one that I call the shooting practice, the NE100. Again, I don't want to go every time and say this is running iOS XE, it has a CPU, you can have IOX, there is security built in. It's the same thing in all those routers. The particularity with this one, it's made to be installed outside, outdoors, it's resistant to almost everything, including gunshots, and it has a battery. The battery will let the router run for about 8 hours without mains power. So it is really installed in places where, for example, on the top of this electrical pole, say there is a hurricane, the hurricane is breaking the electrical lines, there is no power anymore. If that happens and you lose the router, what's the conclusion? I mean, you just lost the radar. You don't know where it is. You don't know what's happening. So that's why we need the battery there so that the radar can communicate. I'm still there, but I've lost this link. I've lost that link. And same goes for all the other radars. So with all the radars surviving with their battery, you can have a better estimation of the situation on the ground. Who needs that in enterprise? No one. All right, so that's one of those radars being installed. So what you see here on the pole is like it's a receptacle that you install on a fixed infrastructure, and then you slide the radar in like this. You plug in there, 2 screws, and the radar is fixed. Very easy to replace. You don't have to do a lot of things. You just remove the 2. Those are sort of screws. And then you slide the radar in, you remove it, you put a new one, you're good to go. Okay, 1800. 1800, as you can see, it has a different form factor. It's flat. Originally, it was made to be installed in vehicles, in trains, for example, underneath a car, but also in places where you don't have a DIN rail, but you don't have also a lot of space. It could be underneath a bridge, for example. But you would say, Emmanuel, if you put that underneath the bridge, then there's going to be a problem with water. And how do you do that? Because it doesn't seem like it's IP54 resistant. And that's right. That's why we develop an IP54 kit for the 1800, which will allow the radar to support water spray to a certain level. Okay, so the kit comes and basically blocks and seals tightly the front and the back of the radar and leaves all the ports accessible. There is also something we do very often in the IoT space. It is the M12 Ethernet connectors. M12, for those who are not familiar, are those connectors here you see on the top. They're round and they're screw-in. So it's like an Ethernet cable, but it's just physically different. You have to connect it and screw it in place. It has multiple advantages. The first one is that it's watertight most of the time. And the second one is that there is no chance that the connector will fall off by someone accidentally touching the connector. And it has happened to everyone at some point, I know. So M12 is really there to be resistant against that, in particular if you're in places where there are vibrations. Okay? The 1800 has a number of certifications, one of which is IP54. It's been certified in Germany by TÜV. And well, you see here this poor little 1800 being bastardized by a resiliency test. So they are spraying water for like a full day on the radar. They are putting the water into an enclosure where they put pressure water, and they do all kind of different tests. So we don't do tests ourselves. We always ask external auditors to do the testing for our radars. And here is the big boy. So that's the IR 8300. So this one is like the jack of all trades. It's a little bit of a switch. It's a little bit of a radar. It's a little bit of a telecom radar because it can do PTP, so IEEE 1588 for clock synchronization, which you see typically on service providers' network. You have also interfaces to put 1 or 2 cellular module. You have a slot where you can have an SSD disk, so you can host applications. You can have NIM modules for T1E1. This one does everything. We use these radars primarily in substation because they also have the certification to be installed in substation. That means they are very resistant to EMF, electromagnetic interferences. But again, it runs iOS XE, it has the same security, it's managed by the same tools. So across all those different use cases, we are reusing the same technology and the same management. Speaking of management, let me just skip this one. I just want to go straight to the embedded radar. I will talk about management on the next slide. The embedded radars, and I told you that before, don't have the enclosure. So you purchase, or we can sell you the digital board with a specific connector that you can use to embed in your own application. Not a lot of people do that, but there are two main use cases: military applications of all sorts, and also some of Cisco partners who are using our equipment in an even more ruggedized enclosure. For example, we have one partner we work with who are building all of our portfolio of products, but with a high ATEX compliance for explosive environments, which means everything needs to be completely tightly closed. You should not have any air going inside and outside the enclosure, which is not something that we do here at Cisco, but they do it. So they purchase the embedded module and they build a super high resistant enclosure out of that. Military, they put it into stuff. Drones, for example, very often. There is also an embedded version that's being used for deployables. So on the battlefield, you have some deployables that you deploy on the field that keeps a network mesh connection alive so that when you have a military on the ground, they can still get network access. Those things need to be very smooth, and it also needs to be cost effective. So this is where these things kick in. Okay? So this is an example here with the ESR 6300. Think about it, it's an IR 1100 that we've seen earlier, but just with the board. There is something special I want to mention here. It's a product called Secure Common Access that I am also personally working on. It's a remote access solution that has been made especially for industrial IoT environments. Now you could say, hey Emmanuel, we already have like 1 million of different remote access solutions, and we have VPNs, and we have TeamViewer, and we have whatnot. Why do we really need, does the world really need another one? And the answer is yes, of course it does. Because Secure Common Access works by running a small agent within the network equipment and use that agent as a proxy to give you access from a secure broker to some of your remote equipments. So we see this in wind turbine environment that they are in the middle of nowhere and you need to access the control system. We see that a lot in factories where you're building stuff. Factories, they have a robot, and sometimes the manufacturer of the robot need access to the robot PLC to do some troubleshooting or reprogramming. Typically, it's a nightmare for them to do that. SCA is Secure Common Access is there to do just that by providing very specific access with also a specific workflow that is called a request approval. So unlike a VPN where you get connected and you get access to everything, SCA gives you access to just one small portion of your network because it's running, for example, here on a switch. And this agent is giving you access to one asset, one port number, to one user, right? With monitoring capability, we can see what's going on. If they're using RDP, VNC, we can do screen recording. So all of this is really adding the value of being able to use industrial product in those scenarios. All right? So that's what we do for routing, but that's just the beginning, because DJ will show you what we do with wireless. Thank you.
Thank you, Emmanuel. Okay, so on the wireless side of things. First off, really when we look at our industrial wireless portfolio, it really overlaps with what we have in Cisco as an outdoor wireless, right? So when you think about industrial wireless and you think about outdoor wireless, you'll see a lot of similarities. And this slide kind of shows a little bit sort of the history behind that, and that helps me explain a little bit about how we move forward when we think about industrial wireless, right? So all the way back in the early Aeronet days, there was this need to take these wireless access points that were traditionally inside and take them outside, right? And that sort of led to the evolution of access points. You can sort of see here that some of these access points look different than others, right? And a lot of that comes from the needs that customers kind of gave Cisco on developing those. sort of during the evolution, and you'll see on the next slide when I talk about the current APs, you'll see how they've sort of have morphed into something very similar to what our enterprise access points look like, which of course comes because the same technology is inside of them, but we've adapted them for sort of more the industrial use cases that you'll see. How many of you have ever used any of these APs before? Okay, good. That's like a good number there. So when we talk about what our current APs are, right? So everything on that last slide was our previous generation of APs. This is what we have from the Cisco portfolio in terms of current outdoor APs today. So on the enterprise side, right, things that are not necessarily, actually they're on this side of your screen, things that are not necessarily industrial, right, but are things that you could use outdoors is going to be the 9124, CW9163. But on the right side of the slide is really what we've kind of come to market with on the industrial side of things. And that kind of completes their portfolio, right? And that kind of goes where I say, you sort of have this there's kind of a gray area, right? What makes an industrial AP? What makes an outdoor AP? Everything about an industrial AP can definitely make it an outdoor AP, right? So there's nothing, there's nothing that keeps you from using that AP outdoors. And that's really how sort of we have kind of evolved the 6E portfolio inside of Cisco, right? So APs on the right side of the slide there, the 9167, I'll talk about that in just a minute, and the 9165, I'll talk about that in a minute, right? But just kind of wanted to highlight, right? Just because they say industrial does not mean that it has to be industrial use, an industrial use case. It could certainly be used anywhere. So a little more about the 9167. This is something that I've worked on for the past 2.5, 3 years, and I think of it sort of as the top of the line outdoor AP that Cisco can offer for the 6E space. Really, as Emmanuel mentioned, everything in it is very similar to what you'd expect with an enterprise access point, right? So 3 radios, 4x4. If you're a wireless person, that's really leads you to the top end of the performance spectrum of at least what you'd expect in an outdoor AP. We support all of the same things that you would in enterprise in terms of software. So we're basically taking that AP and making it ruggedized, right? Which is what allows us to do that. I'll talk a little bit more about some of the special software things that we do in a second. Everything that you'd expect today in an AP, right? Multi-gigabit support, dedicated scanning radios, same as the enterprise equivalents. One of the things that we sort of did a little bit earlier in the 6E, in the wireless portfolio, they are now standard in the Wi-Fi 7 APs, but we actually started incorporating the GNSS receivers into the APs. And that's simply because when you're outdoor and when you're in an outdoor environment or we're in an industrial environment, that's something that can help a lot more, right? Our enterprise APs used a USB dongle, and that's something that you really couldn't ruggedize, so we had to put that receiver inside of the AP so that we could ruggedize it and make it IP67. As Emmanuel talked about, M12 connectors are something that is really useful for industrial use cases, or really anything where you want to seal the AP. So that's why we, step over here a little bit. That is why we incorporate that into our design. M12 is one of those things that can be a little complex for some users. As in the case of our IR routers, they're something that's optional. We've also made them optional. I'll show you that in a second. And just highlighting, right, at the bottom of the list, Cisco Trust Anchor. Essentially, that means for our industrial wireless products, we have the same level of security in our products that you would expect with the enterprise products. And that can be useful, especially when you deploy wireless access points in locations that are sometimes more accessible than most of your network equipment. Think of a parking lot or the outside of a building. It's really easy for someone to gain access to that. And you want to have some level of confidence that that access point hasn't been tampered from a software perspective. One thing to mention here, this is a 9167 series. We have 3 different APs in this series. I'll talk about a little bit more of in depth in a second. But really, We have two different main models, the 9167E, which is an external antenna variant. So if you have use cases where you need to have external antennas, that one works. For the most part, though, a lot of users just need omnidirectional coverage around the AP. That's covered by the 9167I. One note there, this is a 6 gigahertz capable product. And when you're bringing 6 gigahertz to some of these industrial environments, you don't necessarily need it for outside use. So if you're in an EU country or a country that's covered by ETSI or in the UK, you can use the 9167I in an indoor environment where you need something that's a little bit more rugged and still keep that 6 gigahertz support. So something to kind of think about if you need to deploy in one of those areas. We also have the 9167E HZ. HZ stands for hazardous locations. Emmanuel mentioned that just briefly. I'm going to dig into that a little bit more in a second and why that's useful. But we were able to take that same product and adapt it to fit adapt it to meet the certification requirements for some of those hazardous locations. We like to sort of map these APs, just for your knowledge, as to what they fit on the enterprise side. So the 9167 series that I just talked about maps very closely to the CW9166, which is also that 3 radio 4x4 AP. There are some differences there, just in the process where we take the APs and we have to transform them to be something that can meet our industrial requirements. We have to make some changes sometimes. One of those was, of course, as I mentioned, putting in that GNSS. There's no USB port that's accessible on the outside, so you wouldn't be able to plug the USB GNSS receiver into it. And because it is an IP67 box, the environmental sensors no longer made sense, so we had to remove those from the design, which for most environments in industrial outdoor sense is not something that is really important anyway. I'm going to cover the 9165 series in a second, but that maps most closely to the 9162 AP, which is the indoor AP, and also the 9163, which is an outdoor AP. Really the differences there, and I'll talk about those, you'll really see them omitted on the next slide, is the lack of a scanning radio, and the lack of 2.4 gigahertz. I'll talk about why that is in a second, but just noting that here. So the 9165 series functionally is very similar in terms of architecture. One of the big differences is going from 4x4 to 2x2. When we think about some of these industrial use cases, a lot of them are focused on equipment, things like Emmanuel talked about, could be military, but really things like manufacturing, mining, rail, really applications where space is a little bit more of a concern. So we had the need to develop an access point that was a little bit smaller than some of its predecessors. And as you saw on that first slide where I had the history up, some of those APs were a little bit chunky, and that led to issues on trying to put that in equipment where you had a small footprint, small space to put it. So the two access points in this family are a little bit different than you'd expect in most families. They don't look anything alike physically, but actually the board, the components inside of it are actually exactly the same. So the same circuit board that goes in the 9165E is the same in the 9165D. And I'll show you what those look like in a second and kind of reiterate that. But really, the differences there are the form factor, right? Things that our customers have asked us to do. Because a lot of times customers are putting these in enclosures, like Emmanuel mentioned. The 9165E does not have an IP67 case. It is only IP, I believe it's IP30. So it's not something that you can spray water on, of course, but it is something that you can easily put inside of a case. Thinking back to when Emmanuel was talking about the embedded products, we don't really have an embedded product for wireless just because the regulations, the certifications make it very difficult for us to sell just a board and then for a customer to use it. But the 9165E is sort of actually the closest that we get to the smallest AP that you can take and put inside of another machine or another enclosure and do something like that with. But it's also very easy just to use as an AP itself, right? We have customers who just want a small AP to put inside like an elevator or some other small space like that where they're constrained, and this is a really good fit for that. As I mentioned on the previous slide, it does lack 2.4 gigahertz. That was one of the things that we had to give up to kind of make the power and the form factor work. And it also doesn't have a scanning radio, but it's still a 5 gigahertz or 6 gigahertz AP. 6 gigahertz is not something that you can use under the EU or ETSI just because it has the external antenna connectors, so it is standard power only. but it still is a fully functional 2 5 gigahertz radio AP, and it can be used for a lot of different things. Again, one of those kind of things that we adapted to the industrial use case, but could be really in anything, is the presence of GPIO on this. So GPIO is general purpose in or out, which is essentially either relay outputs or digital contacts in, so that you're able to integrate this AP into another system, right? Something that, somewhere that could be possibly used is something like an AGV, where this was like battery powered. The AGV was battery powered. It got power from the the access point gets battery power from the AGV. But customers actually want to shut down their AGV, right? Running on battery power all the time takes more energy, and say, for instance, they want to shut down that AGV, but also want to be able to wake it up really quick, they can use that GPIO to either send a command to the robot to shut it down, or have the AGV send a command to the AP to turn it into a power-saving mode, so they can conserve that battery power as much as possible. This also has M12 adapters, at least actually both APs here. On the 9165E, it is only on one port. Again, this is not an IP67 AP, so in this case, it's only for vibration, not for fully stealing it from the elements. But vibration is really where those M12 connectors really come, really are the most useful. The 9165D, on the other hand, that AP has a IP67 enclosure. Again, same board as the 9167E, but you'll notice the front of it looks a little different. That's actually an integrated antenna. This one's primarily driven for areas where you need focus coverage or a point-to-point link. We have some software options that I'll talk about in a second. One of them is called URWB, or Ultra Reliable Wireless Backhaul. It's focused more on point-to-point links for this AP. But you can also use this AP as just a typical, CAP-WAP AP, so you're able to focus coverage in one location outdoors. Doesn't necessarily seem super useful for the most part when you have the enterprise APs, but think about something like a wind farm. And you have the tall wind turbines. That's actually where we see this AP used quite a bit, is they need coverage up and down the tower of the wind turbine. So they put one of these at the bottom, focused up, and one of them at the top, focused down. So no matter where the workers are inside that tower, they have access. And again, it's something that has a wide temperature range. It's pretty rugged. If it gets hit by something, it's not going to damage it like an indoor AP would be. So what makes an AP industrial grade, right? As I kind of put up on the first slide, we have outdoor APs, we have industrial APs. If you look on the data sheet, the outdoor APs have a temperature range, the industrial APs have a temperature range. They really overlap quite a bit. And really a lot of that has to do with the testing behind it, right? Each of those APs goes into a test chamber, especially on the enterprise side. They go into a test chamber, they're tested, they meet that threshold. But when we talk about our industrial grade APs, we do a lot more testing when we actually say, yes, this AP is going to work down to negative 40 degrees or negative 50 degrees. And yes, it will be able to fully function when we get up to, say, 75 degrees. Because we have customers that actually use it in those scenarios. Cold storage, think of like a freezer, like a walk-in, a really large, like drive-in type freezer, where you have warehouse shelving and you need access points in there. Our customers deploy it in situations like that, right? Where they know that access point is always going to be at negative 40 degrees, sometimes even a little lower, and they need that AP to work for like 10 years in that environment. An enterprise AP is rated for that on the data sheet, but there's other considerations when you think about things like condensation, developing inside of the AP, how the materials of the AP respond at that temperature, and that's really what we're looking for when we kind of take that enterprise AP technology and put it into an industrial product. Here's an example of the inside of one of the castings. So all of our APs are really cast aluminum, something similar to this, but we put a lot of time into developing the AP and thinking about thermals, because really the thermals, or how to get rid of all the heat that the AP generates, is one of the most complex parts of the physical sort of development of the AP. On the left side, that's a 9167. This is actually the 9167i. So the right part of the screen, this part right here, that is the antennas on the front, and that's the PCB board. developing most of these APs, we try to put everything on a single PCB board just to eliminate any issues with vibration causing different components to come apart. Once you start stacking PCB boards and having connectors between them, then the vibration can become an issue. On the left side, it's pretty standard, right? That's the kind of the metal casting. But all of these small towers that you see, I call them towers, but the raised parts of the casting with the little colored squares on them, those are to transfer heat. So each one of those is a small conductive material. It sort of mates with different areas on this, and that's to pull all that heat away. Because we don't have fans. Most APs don't have fans anyway, but we of course don't have fans, and we have customers that are using these in areas that have high temperature or low temperature. Primarily the high temperature is the problem with thermals. We want to make sure that we can get all of that heat off the PCB board, put it into the case, and then the fins on the case help distribute that out into the environment. Similarly, when we talk about 9165, it looks very similar. Because this was so small, we had to fit everything onto a smaller PCB board. As I mentioned, this is actually the same PCB board that's used in the 9165D. But you see those same type of protrusions in thermals. One of the things that was kind of a little bit more complex with this one was 9167 is something that you usually pull mount, or you mount on a wall and you have a lot of airflow around. With this access point, we developed it so that when you put it in one of those machines or you put it on a panel, a lot of that heat actually has to come out the top of it, where the fins are. Because if you put it on a surface, it's not going to be very thermally conductive. You still have that heat that you have to dissipate, which is why most of I don't have a top picture of this, but if you see this access point in person, you'll see a lot more fins on the top. That's because we expect most of that heat to be out there. And that's really just understanding how customers are going to use that and making sure that we developed it for something that sort of aligns with that. Here's a comparison between a sort of enterprise outdoor AP and an industrial grade AP. On the left is a Catalyst 9124, so that's a Wi-Fi 6 AP. Those APs, this AP on the left, actually has sort of its own, not really proprietary, but its own special connector for Ethernet, where you plug the Ethernet cable directly into a port on the outside. That's how they do the sort of the weather sealing or the IP67 protection of the AP, and you'll see that here. You have these small connectors, so you actually plug the cable into that connector, and then inside there's just a little short piece of cable that goes into an RJ45 port. So even though you're not plugging directly into the PCB board, there is still a short cable inside that AP that can have issues with vibration, right? So imagine putting this on something that has a lot of vibration, think of like a train. Potentially, over time, that cable could start having issues, right? It could vibrate loose, that connector could come out. You know, just as you'd sort of a picture, you're just relying on that little tab there to hold that cable in, even though that's not what you see when you plug into the outside of the AP. On the right side, 9167, similar PCB inside, similar construction, but we sort of opted to go with RJ45 ports directly on the board. Similar to 9124, right? There's still a RJ45 on the board. But the idea here is that you actually plug the cable through the chassis into that port, and then you use a gland that you screw down on it that holds the cable in place, right? So it still has that RJ45, the same tab, but you're actually captively holding that cable in place. That way, as it vibrates over time, you have a positive way to keep that cable in place. You're not reliant on that little tab. If you have even more vibration, then you can use M12 ports, and I'll show you that in a second, what that looks like. Here's what those ports look like on the outside. If you were to look from the outside when you're plugging that cable in, that's the same port. It's on the board there. SFP port here has just a GLC TE or a copper SFP in it, holding it. So typically, these threaded, you take a gland, you put that on the cable, you screw that down, that holds that in. But if you need more, as Emmanuel mentioned, M12 is quite popular. We didn't want to make this AP something that was difficult to use for all customers, right? So if we were just to put M12 ports on it, like we had in some previous APs, that causes issues. If you just need a rugged AP and you want to use it outside, you don't want to necessarily always use M12 ports, right? So like you just saw on the last slide, you can take a normal Ethernet cable, plug it in the AP, and you're on your way. But if you need something more, something either because you need the IP67 protection, or you need vibration resistance, we have these adapters. So these are essentially M12 adapters. So the port that you see on this side is an M12 connector. We have it for both power. So this one right here is power. You notice this one in the middle is what they call M12X code. It has 8 pins, right? So just like your typical Ethernet cable, you have 8 pins. It's just a different format. So rather than being RJ45, it's M12X code. And this one on the right, also called M12, but it's actually called M12A code. It has 4 pins, and those have a special pattern that's used for power in most industrial equipment. This is what those connectors look like from the back, right? So as I mentioned, the board has the RJ45 connector, so you still need to adapt to the RJ45 connector. But when you screw this adapter into the access point, it actually holds it in place inside the RJ45 connector, so there's no worry about vibration getting it loose, right? So you screw down these 2 screws into the chassis, and this is pressed and held into place in the RJ45 port. With the power, it's a little different. It does have this short cable here, but then you have this connector that plugs into the power connector in the AP, and it holds it in place. What it looks like when you're installed is like this. So you screw down these screws. This over here, that was that SFP port with the SFP, the copper SFP in place. You notice there's a little bit of a adapter plate that we put in place here. That accounts for the difference in depth of where that SFP sits. But you're able to transform that AP from essentially what was a normal AP with RJ45 ports into something that had M12 in situations that you needed it, with just a few extra adapter parts without having a completely separate AP. Once you have those all installed, it looks something like this, right? So imagine you're installing this in a train or in an outdoor environment where you're worried about your water penetration and you don't want to use glands. You can use a cable like this and not have to worry about that. That keeps your AP fully sealed. I mentioned the Haslock version of the AP at the very beginning, or the 9167E HZ. Just some differences here to think about on things that we go through when we have to develop an AP for that environment. If you're not aware, hazardous locations really have to deal with environments that could be potentially explosive in most cases. I'll give you some examples on the next slide. But think about things like a chemical industry is one of the ones that are the most obvious. So environments that potentially are hazardous mean there could be something that happens like a gas leak or dust release that could potentially be hazardous. And I know I keep saying that, but it's a case where it's not always present, but it could be present, right? So it's more likely to happen at some point in time. And the idea with a hazardous location AP is if something happens and you do have that gas release, you don't want your access point to suddenly ignite that and then have a big explosion or a fire, right? So when you're in that type of environment, you really have to think about all the equipment. But nowadays, everyone wants wireless everywhere. And to put an access point in that location, you need to kind of think about which, you need an access point like this that is rated for that environment. So just some of the key differences for this type of AP. As Emmanuel mentioned, we have to do a lot of extensive testing sometimes for these certifications. One of the certifications that is required for the hazardous APs is we actually have to take small metal balls and shoot them at the AP at a certain rate, at a certain speed and velocity. And the idea there is to make sure that, if something did explode in this environment, that like shrapnel or things flying from that wouldn't cause the AP to be damaged too easily, which could lead to another issue. So it's not quite like bullets, but sort of like that. So you actually notice here on top, this is actually the GNSS port of the AP. So it uses a TNC connector, which is a little smaller than a normal N connector. And it was actually too weak to pass that test without some additional protection. So we had to develop this small little bracket here that goes on top of the 9167 just to protect that port so that it didn't get damaged too easily to pass that certification. Other, kind of small, minute changes. The vent cap, or what equalizes the pressure inside and outside of the chassis, it's plastic on the normal 9167E, which is more than enough for most conditions, but it did not pass the temperature requirements for the Haslock certification, so we had to replace it with a metal one. And also in these environments, it's not just the AP, but it's the entire installation that often has to meet these certifications. So we actually had to allow for larger ports, just because larger cables in the environment mean larger connectors, which means larger glands. And occasionally, even like this is a metal pipe that you connect to the AP. Some customers have to do that just to really protect their cables in these environments. So we had to actually develop special adapters there. So that's kind of an example. And of course, the obvious difference there, the hazardous certifications for these APs are not just the hardware themselves, but actually the entire manufacturing process of this equipment has to be certified by these third-party bodies. Sort of an example of what are some hazardous environments, like I mentioned. There are 3 different bodies that actually develop these certifications or the code for them. It gets a little complex, but for the most part, in Europe and at least outside the U.S., it's going to be ATEX and IEC-EX that develop kind of code for them, and then different laboratories test against those standards that we have to meet. I mentioned chemical industry; that's the most obvious one. But the reason I bring up this full list is a lot of customers and enterprise realize, even though that you don't do something that's industrial, you may have an environment that you might need an AP like this in. Things like metal shops, woodworking, they can produce enough dust or use gases that may require some of the environments within inside your facility to need hazardous location APs. Some of the ones that sneak in, things like food industry, they use specific flavor additives that when there are in the atmosphere as dust could be explosive. Pharmaceuticals, they use the same either products that generate dust or gases. And then things like paint shops, right? Like if you have a vehicle service facility, both the maintenance area, those where you work on vehicles, and maybe you have hazardous things like gasoline that can produce fuels, or you have a paint shop that paints. Both of those could be a potentially hazardous environment. Question?
Yeah, how is it about cleaning with alcohol and so on? If there's any effect of the antennas or on the body?
Sure, so the question is, does cleaning affect the body of this? So there's really two parts to that question, right? Some locations like clean rooms, some of the agents themselves can be potentially explosive, so clean rooms is one of those locations that we see. In terms of the actual construction of these access points, they have the same powder coating that most of our enterprise products do, so it's not much different there. But we've looked at a number of different clean room agents that you wash down this equipment with, and for the most part, the powder coating, the aluminum alloy, doesn't have any issues with that. The antennas are plastic, so the question again was about antennas. For these hazardous environments, we have certain requirements for the antennas. So between the non-HAZLOC version or the non-HC version and the HC version, there are differences in which antennas you can use. This is a smaller list. All of the antennas that we have for the hazardous APs have they have different they have different UV inhibitors for things like sun, so the sun doesn't break them down, which would also lead them to be a little bit more resistant to chemicals. But they also have different flame resistances, right? So if something were to burn or start on fire, the emissions produced by the antenna burning is within a certain threshold, just so that you don't cause the dangerous gases and stuff. That is not necessarily limited just to the HAZLOC use case. That's also some of our other certifications, things like rail. Some customers put not necessarily this access point, but the standard access point inside of a rail car or inside of a tunnel, and they have certifications requirements that if something were to happen underground and the area were to catch on fire, you don't want the AP to produce too many gases in the environment. Anyway, so you get the idea here, right? Even in your enterprise, you may have some need for an AP like this, and really, the AP internally is the same as just like any other enterprise AP, but obviously is built to withstand those environments. And I have it leaving. So really quick, just kind of a follow-up to the hardware. Obviously, our hardware is unique when we talk about industrial use cases, but we do have some technology sort of to support that. Like you would expect in your enterprise APs, we support everything else, right? So CW controllers, CW9800, any 9800 or CW9800 controller, the experience is going to be the same, just like with your indoor or enterprise APs. You can use Catalyst Center to manage those. But we've sort of also developed some of our own technology for industrial use cases, one of the primary being ultra-reliable wireless backhaul, or URWB. And really the focus there is when you're connecting people, Wi-Fi is great. When you're connecting things, like we talked about from the beginning, it doesn't always work so great, right? Because you have issues with roaming, and also just sometimes you want to connect a group of things in a certain location, right? Like its own, you may have a switch on a vehicle or a switch in a remote location. That's really where we push you more towards ultra-reliable wireless backhaul. So what is URWB? It really can do two things. It can do those fixed links like I talked about, right? Where you want a point-to-point link maybe between a building and maybe a chiller plant that's at the edge of your building that helps cool your building, or power metering infrastructure. Lots of use cases there for sort of that. But it also does mobility use cases. And mobility use cases are things like AGVs, any type of vehicle, mining, trains, but inside of most enterprises, you also have some things are like this. We see applications in healthcare where you may have mobile carts that you need to move around, where you have a lot of different equipment on that cart. All sorts of use cases there. And URWB essentially improves upon Wi-Fi where you have issues with Wi-Fi and roaming. We sort of do away with the roaming and can make that a little bit more reliable, producing lower latency, high reliability, things like that. We also kind of cater specifically to Workgroup Bridge. How many people in here have used Workgroup Bridge before? Okay. There's a lot of history in Workgroup Bridge and Cisco. One of the things that, as many of you probably are aware if you do use it, is we had an AP, the IW3702 AP, that we end-of-sailed a little bit ago. It was really the last AP that did Workgroup Bridge in iOS. Now, of course, we're transitioning to iOS XE. On the 9165 EAP that I presented, that's really where we kind of took that and made that the kind of the replacement to the 3702 AP. And specifically for Workgroup Bridge, we spent a lot of time making sure that we could meet the performance of the previous generation of AP. If you're not familiar with Workgroup Bridge is essentially like a Wi-Fi client mode for an access point, right? So if you have something you need to connect to your network that doesn't have its own wireless interface, or maybe you need like WPA3 and it doesn't support WPA3, you can connect that device Ethernet into an access point, put the access point into Workgroup Bridge mode, and it joins your network like it was a wireless client. But kind of unlike a single wireless client, you can actually connect 20 wired devices, right? So you can plug a switch into the AP, put up to 20 things behind that access point, and have them all look like they're clients on your wireless network, right? So they join your wireless network, they show up in the 9800 controller as clients, but they're actually sitting behind that AP in Workgroup Bridge mode. The roaming is a little bit better when you're using Workgroup Bridge mode, just because we have the Cisco infrastructure, we have the Cisco AP being Workgroup Bridge mode, we can make some improvements to roaming. One of those examples on the 9165, because as a client, it has those two 5 gig radios. When you're using 5 gig, we can do something called dual radio scan handoff, which sounds really complex, but just as a very quick slide here, we're actually able to use those two radios, and rather than having one disconnect and then have to do scanning and connect to another one radio can stay connected. When the AP triggers scanning, we connect with the second radio, connect to the path the WLC is already established on that second radio, and then we just move the data path from that first radio to the second radio. And then that continues going the opposite way, where we go from radio 2 to radio 1. But doing that, we're able to actually shorten the time that roam takes, or the effective time that you lose traffic, quite dramatically, because all the authentication, scanning, that all happens while the first radio is still serving data. With that, I'll turn it over to Albert for industrial switching.
Okay. Man, who thought we were going to talk so much about M12 connectors? That was that's one of the things you talk about when you find out about you're doing ruggedization, that we really differentiate. That okay, we're going to make sure these things are waterproof, dustproof, vibration-proof. And so when we talk about switching, first we'll step back and talk about the history a little bit. The very first Cisco industrialized switch was the Catalyst 2955. Does anybody remember or install a Catalyst 2955? You may date yourself, but it's been 20 years, right? There we go, there's a few hands, okay, good. Yeah, we've come a long way since then. Really expanded the portfolio quite a bit. But yeah, so some of the things you'll see with a lot of things like what Emmanuel was talking about with routing, size does matter. You see that our devices get placed into like really small cabinets that are quite enclosed. You'll see over there on the left side is a couple where we have some DIN rail products and they're mounted on this DIN rail. You can kind of see the DIN rail here. If you don't know what a DIN rail looks like, it's this particular rail here, and the switches just sort of click onto that in the enclosure. It's a standard way to put things into an enclosure. We also support, we have the 19-inch here. In this case, it's not going vertical or horizontal, but it'll go vertical. We do make ruggedized products, and they'll go in either direction. And not to be outdone, we also have our own M12 products here. This is an IP67 switch with M12 connectors. We didn't want to be the only ones without IP67 M12s, so the switches have them too. But we're not going to go into the details of an M12 connector. Thanks, DJ, you got that covered. Of an overview of the portfolio. Within the industrial switching portfolio, the one on the right-hand side here, or your left, is that's our DIN rail products. We have quite the family there. We have a family of rack mounts, IP67s, and then just like the routers, we also have embedded boards that we sell as well. Again, for partners, same. We're doing like Department of Defense, aeronautics, things like that are all using those. Again, all these products are running iOS XE, just like the Catalyst do, managed by Catalyst Center, and have gone through all the trust anchor, just like the routers and access points. So very standard stuff. We're leveraging quite a bit from the Catalyst already. One thing I like to do, so you can sort of like, because we've been doing switches for a long time, and some of these switches that we have available is, where did it come from? Because we talked about earlier how we mentioned we like to leverage the enterprise technology. So where are we leveraging the enterprise technology? And if we can, use the same ASICs and CPU infrastructure if we can. So this has been happening over time. We came up with the IE1000. We needed something really small and boots fast and has a very sort of easy access. And so there was no Catalyst switch that would sort of fit that. So there's no direct map to a Catalyst switch. It's not using Cisco's hardware technology, and it's not running iOS. If you've ever gotten used to the IE1000, it's quite frustrating. The CLI commands are practically gone. It's a web UI only device. It's built specifically for very simple deployment use cases for people who don't really care about network administration, don't want to do network administration. They just want to be able to get it up, give it an IP address, give it a host name, and turn on a username and password and just go. And just start connecting things to it. So it's very for really simple use cases. And we no longer are selling the IE2000, but this is a very popular product for us that we sold throughout between 2010 and like 2022 or 2023. When it comes to like sharing what we're sharing with enterprise is really based with what we had on the 2960. So think all the way back to the original 2960. And then when it came up with the 4000, this was very similar to what we had on the 2960X. You can't tell because of, like if you look at the IE4000, it was probably a black cube. It's hard to imagine it was the same thing as this 48-port 2960X, but in fact, we were using the same ASIC and the same CPU technologies using there. And then we needed the next generation of products. So we had the what we call the IE31, 32, 33. And at that point in time, when we needed to come out with this product, there was no Cisco ASIC that we could cool and put into a small DIN rail form factor. So we had to go outside of Cisco and went with the Marvell ASIC. Now, for the most part, 99% of the stuff still works the same, but you'll notice there are some small differences between, say, for instance, how like RSPAN works. So there's a difference in how RSPAN works on, say, on the 3300 than it was on, say, like the Catalyst 9200 or something like that. So little small differences, and they're all based upon the hardware. And why is that? It's because we're not using a Cisco ASIC on that. But then came around, and so we were able to get a version of the Doppler G that is uses enough power or a little enough power that we could cool it in a 19-inch rack form factor. We're going to show you a couple of examples about how we're going to cool that. And we did a really good thermal job on that, and it really shows off how the hardware team is building those products. So this is sort of the portfolio of the 3300. So the 3400 is our most advanced switch, supports TrustSec, also supports all of our replication technologies when it comes to redundancy, so like PRP and HSR, if you're familiar with those are quite advanced. And then the 33 and the 34 also support expansion modules, so they all come with 10 ports on the base module, but if you need additional 8 or additional 16, you can get an expansion module for those. And the 32 and the 31 are really supposed to be there for just pure layer 2. There's no like dynamic routing capabilities, no advanced switching features, and that's sort of more entry-level type products. So this is what one would look like if it were deployed in a cabinet. The interesting thing about this slide, and why I included it, is you can see there's the power supply here. So this is an example of an AC coming in and then DC going out. All of the Cisco the industrial switches, they all just take, at least for the DIN rail mount anyway, they take DC in. And this is what it looks like. We have 2 DC connectors. In this case, there's only one DC source. That's all you need is one. Obviously, 2 would be great if you could be redundant. The interesting thing about this is it's laying on its side. So it should have been another 90 degrees and done right side up. When we design our products for the thermal design, we always design as if they're going to be placed right side up. If the hardware team were here today, they'd be jumping and shouting. They don't design things to operate like this. They say, oh, if this cabinet gets hot, we can't guarantee that the switch will operate under these conditions. Like, relax, the switch is going to work. It's not necessarily 60 degrees outside, 60 C anyway. Anyway, so it's going to work just fine. I thought that was interesting because you see how the power supply is also there. We have another example of the same, a very similar one, not quite the same. Again, for some reason, they get the power supply oriented the right way, but in this case, the switch flipped up 180 degrees. So now, the bottom is on the top and vice versa. And again, from a thermal dynamics perspective, because it's all about getting rid of the heat. All of the hottest components on the switch inside are placed sort of at the top of the PCB board, so all of its heat dissipates up. And when you flip it upside down, you put all the hot parts on the bottom, and it's going to heat up the product internally a little bit more. So that's not ideal. Of course, the switch will continue to operate, but if the ambient temperature in this cabinet was really hot, you might have all of a sudden some issues with your internal temperature thresholds being getting hit or triggering.
Should add an arrow in this point up.
That's not a bad idea, actually. His comment was you should have had an arrow, just like this side up. Yeah, that's not a bad idea. I'll bring it up to him.
You need to give me the credit.
Okay, by all means, give me your business card afterwards, and I'll make sure you get credit for it. We'll give you 1 penny.
Why not per switch?
Per 100.
Oh, okay. Fair enough.
So we also have a set of IP67, IP3400 heavy duty switches. We've got the different models here are between 8, 12, 8, 16, and 24 ports. Again, they have, DJ alluded to this earlier, they have these X code and D codes. So when we have on our products, if you're ever tried to put one of these through and do it, configure it, they have this fast E and GigE, and you have to pay attention to that because the port speeds are fixed on these, depending on whether it's X code or D code. So if you buy the FE, that means you need the D code cable because it only has 4 pins. But if you buy the GigE version, that means you need the X code cable. So if you made this mistake, you've gotten really frustrated. You probably only make it once, and then you realize, okay, next time I'm going to buy the right product. Because if you need gigabit, you have to have the X code cable. If you need 100 megabit, you have to have the D code cable. All the joys of X code and D code and M12 connectors. But anyway, these are some of the use cases that DJ brought up. They're for like HAZLOC locations, paint shops. We see this sometimes with tire manufacturers. There's a lot of sulfur in the air in tire manufacturers. We like to recommend them going with these types of products. On the IA9300, this is our latest rack mount products, wide variety here. Got to pay attention to the feature support. Not all of them support PoE, but some of them support PoE. Some have 10 gig uplinks. Some of them have 1 gig uplinks. Some of them are supporting GPS, so if you're really interested like in precision time protocol, we can take GPS or iRig-B in, so pay attention to the specific models and the features on each. But quite a wide variety, and they all take their the powers in the back. So this is what I was talking about earlier about how we do the thermodynamics. So here we're taking the same ASIC that's running on the 9200, the Catalyst 9200, but here we're going to make it work in a fanless environment. So we have this demo unit that we have with a plastic cover on it. And what you're looking at, you can see they have these copper conduits. So we've identified where the heat sources are, and because it's all ambient, it's all like dissipated through the chassis, one of the things that we're doing here is we've got these copper conduits, and so this is where like the ASIC and the CPU cores are on this particular board, and we're going to actually carry the heat over to this. So we put a hole in the chassis, put a hole in the top of the chassis where they put a grill so the heat can escape. And we've done the same thing on this side. If this happens to be, you can't tell here, but this is an 24 ports of SFP. So all the SFP ports, there's like 1 or 2 watts per SFP port that we have to cool, but with no fans. So we're carrying that heat from those SFP interfaces over here, and then we have another grill here to carry those away. So the thermodynamics that we're doing is really the big thing when it comes from a switching perspective. How are we doing it? How are we doing it thermally? So how are we cooling this product without any fans? And that is really a lot of the engineering that goes into this. And this is where, having been doing this for 20 years and having to develop thermodynamic evaluations and understanding the thermodynamics of the different components and putting them in these ruggedized products, doing it for 20 years really pays off. And we've had the same engineering team working on this for, close to 15 to 20 years. And so those guys have got it down. And so it's not just the thermodynamics, it's all the compliance for shock and vibration and all the compliance for utilities, oil and gas, mining. So it all sort of goes into the old engineering part of it that those guys are doing really well. So let's compare it now with enterprise switching. So we talked a little bit about like a lot of the thermodynamics in the M12s and things, but beyond that, if we just take a look at a 9300 compared with, so we're sharing the ASIC with the 9200, so what's sort of the difference? Well, you can already see like the temperature extremes. So the Catalyst, really wants to be in an air-conditioned environment. So it really tries to control that. The other thing is because they're using fans and we're fanless, one of the other things you'll see is you have a high MTBF factor. Without having any moving parts on the product, the lifetime of the product really goes up quite tremendously. And we also buy our components, so the hardware components are a little bit different, like memory chips and things like that. Or we get the industrial grade memory chips where they can use like enterprise or commercial class grade memory chips. We have to buy actually different components that are actually higher in temperature internally. So we're not using the same components as them because we're buying more industrial temperature grade components as well. So we're exceeding what they try and do in sort of enterprise level for shock and vibration. Same thing with corrosion. We have to understand where there's corrosive environments. And then one of the things we chose to, instead of naming this like IE 9200, why do we call it IE 9300? Because now we're confusing everybody, thinking this is actually like the equivalent of a Catalyst 9300, which it is not. It's actually the sort of technical equivalent of a 9200, but we added in sort of app hosting and some other capabilities that we built. So we felt like from a marketing perspective, this was more than what a Catalyst 9200 was. We couldn't call it an IE 9200 because we're exceeding the capabilities of a Catalyst 9200. And then, so somebody had the idea of like, why don't we call it, an IE 9250? And then that got shot down. And so they went, well, let's just call it an IE 9300. And I said, well, that's going to confuse everybody, but I didn't. My vote was overdone. Anyway, marketing guys, what are you going to do? So some of the things that we do, in addition to what we do with from Catalyst. So very similar to what we do with the routers. We've actually added a lot more features on our products that the Catalyst team doesn't support. So a lot of industrial protocols. You may recognize Profinet, SIP, Modbus. We also host applications. We talked about CyberVision, or we talked about secure equipment access, so we support that as well, CyberVision. We have additional redundancy protocols as well. We see this a lot for layer 2. We get deployed in a lot of layer 2 for utilities, manufacturing specifically. They have their own unique aspects and requirements for communication loss and how to prevent that. So we've added some additional ones to that. We also have a problem in manufacturing environments specifically where there's a lot of duplicate IP addresses, and it's done on purpose. So they purposely duplicate IP addresses, and then they throw it out to the network team and say, okay, you have to solve it for us. So we have this feature called Layer 2 NAT, where we can resolve duplicate IP addresses at the Layer 2 switching, so it doesn't require Layer 3 interfaces, and we can do NAT translations on Layer 2 switching. And we obviously added some other enhancements. So for instance, we support the SD swap card. A lot of customers understand that when there's a switch failure, that if it's a switch failure on Tuesday at 3 a.m. in the morning, whoever's on site is not necessarily going to know how to install a switch, but time matters. So you can just take one switch out, put a new switch in, take the SD card from the old, put it into the new, up you go, same configuration as before. You don't have to be a network administrator or CCNA or anything in order to be able to do that. It's one sheet of instructions, and anybody that's on site can do it. So that's a big. The other thing we have is external relays, and I'm going to bring that up. It's really kind of nice that we have the capabilities of having these external relays. You'll see in a second, it allows you to do some rather unique things. So for instance, if you're on a manufacturing floor, any kind of floor, we had all these different cabinets out there, and you had a switch in every cabinet. You had 100 of these, and you didn't have a very good naming convention, so you didn't necessarily know which switch was in which cabinet. You could put a little light on the cabinet and hook that up to the relays that are on the switch, and then you could actually go onto the switch and turn that light on. So you issue a command, it'll trigger the relay on the switch itself, and that will turn the light on. So you could just go, you could SSH into the switch, execute that command, the light on the cabinet would turn on and say, oh, switch XYZ is over there. So if we want to go and manage that switch, replace something, plug something in, or turn something off, you just have to go to that cabinet and open it up. So we also have input relays and output relays, but this is sort of a unique thing that we have on our products that you don't find on the Catalyst products is these relays, these input and output relays. You can also use them to drive alarms. And so one of the things we also support is CyberVision. So CyberVision is something that we've introduced into the industrial portfolio, although the Catalyst 9300 does also support the application of CyberVision. But this is really to help with the securing in an industrial environment where you have assets where there's no usernames and passwords. So all the IT devices, they don't log in, right? They just sort of come up and start working. So how do you know what you have, and how do you know how you want to secure it? So CyberVision is a visibility tool that uses an application that runs on the switch and does a deep packet inspection of all the packets that go over the switch. So over time, you learn all the devices that you have connected to your network, what devices are they communicating with, using what protocols, and how often, and things like that. So this is a quite unique thing that we have because we can host applications right inside the switch itself. You don't have to have any external devices. You don't have to run RSPAN across your network and things like that. It's a whole other thing that we have. So that's the switching part. That's what makes switching industrialized. So it's a lot of the thermal dynamics, as well as a lot of additional software features that we've had in order to get into like manufacturing spaces and utilities and things like that. You want to come on up for some talks about the use cases? We're going to wrap this up here. Got about 10 minutes left.
Sure. I promise. I promise not talking anymore about M12. We're all done there for today. Okay, so some use cases. These are not necessarily industrial use cases. We're just kind of highlighting some of the ways that we've used industrial technology outside of what you think when you think industry. Theme parks, I actually joined Cisco a few years ago, and I came from a theme park as a network engineer doing things like roller coasters, dark rides, all those things like when you go to Disney or Universal that you see. One of the ways that we use our wireless technology specifically, and also industrial switching, not so much routing, but mostly industrial switching and wireless, is powering all the rides that you see at theme parks, right? There's a huge drive for like connectivity, right? As theme parks grow past just what every year they're trying to come up with new things. They need a lot more of that wireless connectivity, especially in motion. Things like URWB, when you're connecting those rides as they're moving around, oftentimes now just without any type of cabling or rail or anything, just around. Same thing with high density wireless coverage. When you go into a park or something like that with Wi-Fi, you don't really think about that unless you're a wireless network person. Then you're probably looking up like where all the APs are, somewhat like you do when you're probably around here. But there's a lot of spaces that you need sort of APs that are beyond what you have in enterprise, right? Some of our APs, they like to go out and they paint and they hide. They put in plants. They put in light poles. It really helps them sort of deploy and make sure that they can have wireless everywhere. Another use case, actually, where we used our industrial equipment that you may not think about is actually autonomous racing. Cisco a few years ago, specifically IoT or industrial IoT that we're part of, sponsored the Indy Autonomous Challenge, where a number of universities were trying to build sort of the world's first Indy race car, but put a computer in the driver's seat instead of a human. I'll skip the rest of the stuff. You can feel free to read that on the slides if you want. But really showing you, sort of what happens when you need connectivity on, and these are Indy light cars, right? So a little smaller than Indy cars, but typically, if this were a sort of real car, this is where the person would sit, right? But there's the headrest, and then they drive the car. But when you take out the human and you put computers in their place, literally, as you'll see in the next slide, in the place where the human goes, you need some way to connect that. I'll show you a diagram in a second. But essentially, this race car had a lot of different Ethernet devices on it that needed to be connected. And we, as being the sponsors, they came to us, obviously, and said, how do we connect all of these devices together in a switch that we can put in a race car? And we sort of went into our product portfolio and said, what switch do we have that has a good level of vibration and could be DC powered and all those other things that we've talked about, and how do you put that in something like a car? And very interestingly enough, we came up with a rack mount IE switch. This switch is one that's really intended for utilities in substations, but it had all of those boxes checked. So what we ended up with is something that looks like this, right? So same sort of car. Again, this is the back of where the driver would sit. And in their place, at the very bottom, is a sort of industrialized computer that is actually running all the AI and algorithms that drives the car. And on top of that, a bunch of different stuff, sensors all around the car that we had to connect. We stuck a rack mount switch inside of there, right? So you can sort of see the front of that here where all those ports connect. This is a zoom in of that. But really, one of those IE rack mount switches in the car and everything connected to it, at least everything that was Ethernet. You can dig in on the PDF slide version of these slides for everything that was connected, but about half of those sensors and equipment in that car was CAN bus, which is a serial protocol, and the other half was Ethernet, just simply because things like the cameras that they need, each one of those is about 1 gigabit per second, plus some LiDAR scanners and a number of other things. They actually surpassed from this switch to the computer what they could carry on a 1 gig connection. It was about 3.5 gigabits of data. So another reason why we chose this switch was for the 10 gig uplinks over here. Or actually, in this case, it was 1 gig uplinks, but they were able to lag for them together to go to the server, so they had enough throughput to actually take all those cameras feeds and put it into that server. And again, that server is on the vehicle, and all that is being processed locally, but of course, they needed some wireless from the vehicle to the wayside, so they utilized our URWB technology for that. I'll mention that in a second. Again, this is sort of that diagram of what that looked like. All those cameras connected to the switch, connected to what's an AdLink, I think it's DLAP in this. That was that processing brain, along with all those CAN bus things connected below it. But and another picture of that switch. But you wouldn't necessarily think of an autonomous vehicle and say rack mount Cisco switch in there, but that's what we thought, that's what we came up with, and it worked pretty well. I'll talk about the results of that in a second. Back. Speaking of that, these race cars were designed to go 185 miles per hour. In kilometers per hour, that's just a little bit under 300 kilometers per hour. But one note here is during some testing, not necessarily on a track, this was actually on a straightaway, but with the computer driving, going down a straight track, they actually set the Guinness World Record for a autonomous race car, and they set that 309.3 kilometers per hour. With all this equipment in there, the computer driving, which is pretty remarkable when you think about something that fast, completely reliant on its own internal processing to do that. Of course, with all that technology, we had to actually connect the vehicle on the racetrack. Not so much anymore now that this was about 2.5 years ago. Now that the vehicles are sort of matured and they can drive themselves, they need a lot less connectivity. But the first sort of year of this challenge, the cars did not do so well driving themselves. There was at least one instance where it drove itself into a wall, but for the most part, the car was just stopping on the track as those teams had to go out and rescue it and get more data from that. So we had to build a network around a track. This is an example of Indianapolis Motor Speedway in the US, where we took that URWB technology and put it around the track so that they could always have really low latency connectivity to the vehicle. And again, you could potentially use 5G for this, but actually in this case, there was really very little cell coverage out in the extent of the race track area, because most of that cell coverage was focused on where the spectators would sit. Sort of another little diagram here you can take a closer look at if you wanted to. Just to point out, of course, we had all that equipment in the vehicle. Another look at that switch there. Here I am, like 3 years ago, setting up one of those switches in that vehicle, and you can sort of see these URWB antennas on top that we placed just to communicate. One reason I note that here is if you go to Hall 5, which is it's actually a CDA booth. It's right next to the DevNet area. There is a Polytechnico car there. It's sort of like a race car. It doesn't look like this. But the same equipment that you see here, albeit a little bit different IE switch, is actually in that car. You'll see those same antennas on top. They've used the technology they got from that to go out and drive that car around the streets of Milan. And if you go to them, they can tell you more information about that. But it's just interesting, kind of the evolution of that same industrial technology, same Cisco technology into industrial technology, and now something that drives race cars around. Just another note here, of course, when we build out that track network, we needed switches around the track. So of course, we went for IE switches, both a DIN rail mount switch and an enclosure around the track for all those APs that we had to put out, and a rack mount switch. Actually, this is a great example. We didn't actually start here with this switch. We actually had Meraki switches that were out in the pit areas, and during testing, those Meraki switches actually overheated, stopped working, and we're like, well, the next time we come back, we brought a IE switch in a case because it was not going to overheat in the sun.
I just want to say one thing is I noticed you got the 3300 to right side up. That's a good job, man.
I did.
He did not need the arrow. He did not need the arrow.
There is more of a backstory on why people put it upside down. So if you want to know that, you can come up and we can tell you the backstory. But anyway, yes, we did put it up. And this wasn't even me. This was actually a third-party company that did that. Anyway, we'll continue. We just have a few minutes left. Another one of those examples that Emmanuel mentioned early on is wind farms. Wind farms, specifically those out in the ocean or in the sea, off land, right, where they're surrounded by water. Another place where we that you want to think about that uses a lot of our technology, IE switches, just because you want something that is built for the weather. The inside of the turbines are not heated, especially at the bottom where there's no machinery. So they're whatever temperature it is outside. And access to them is very difficult. You can't just go out to them whenever you want. The seas have to be a certain condition and everything like that. The other area that we actually use it is on the vessels that house the crew that go around and service them. That crew is pretty much on that vessel in that farm the entire time. and they need wireless connectivity from that vessel to those wind turbines, not only for maintenance of those wind turbines, but also to get data for the vessel for things like phone calls, internet browsing, everything else that you would need living at sea. For the most part, there is no 5G cell coverage out in these areas, so they have fiber cables that come up to the wind turbines, and then they have wireless from those wind turbines to that vessel, just so that they can move around anywhere and still have connectivity. We have an entire architecture for this solution. If you go to cisco.com/CVD, you can find that. There is more info on the next slide. It's not just wind farms. We have CVDs, or Cisco validated designs, for a number of different industries. We have a whole team that develops these, and they do more than just say, oh, this is how Cisco technology goes together. They do a lot of extensive testing. This is an example of some of the test equipment that they have for traffic lights, right? So stop lights, green, red, yellow, as well as other traffic management solutions, things like digital message signs that have messages along the road. This is just an example of what the lab looks like. It's this way for a lot of different test beds, but they actually have some of the real equipment in their lab that they do all this extensive testing with, just so that we can recommend the best thing to our customers. If you want to learn more about IoT, we have, still coming up this week, a number of different sessions. Right here, you're already in our session, so thank you for that. But we have a number of upcoming sessions that if you want to check out. If you don't have anything on your schedule, you can look into that as well. Again, if you have any questions for us about what we presented or anything IoT, you can use the WebEx space. If you go to the event app, you can join that space, and we'll reply to that. Also, make sure to fill out the session for this survey. If you attend 4 sessions and 4 or more, hopefully, sessions this week, and you do a minimum of the 4 surveys, you do get a Cisco Live t-shirt tomorrow. You can fill out those surveys, of course, in the Cisco Events app or online. If you want to continue learning more about it this week, if you visit us in the Cisco Showcase, we have the enterprise networking wall, and we have an IoT table. All of the products that you saw today us talk about, including looking at the M12 ports, you can come do that. We have all that equipment on a table. You can actually feel, touch, and look at it in person. Other things. We have a lot of different sessions that we cover in IoT. We're not always able to cover them at every Cisco Live, so if you look in the on-demand catalog, a lot of them are there, including the session today and all the ones this week. Those will be available March 3rd. Other than that, I'd like to thank you for coming. And one more thing I'd like to thank is Albert here. So this is actually Albert's last breakout session. Over the last 20-some years, going to 30-plus Cisco Lives, doing over 50 breakout sessions. This is the last one that he decided to do for you all. So round of applause for him, and thank you for coming.